DKP Sogong aboard. Your learning journey starts now. Ever wondered why primes are so darn mysterious? That million-dollar question, the Riemann hypothesis, might just have a new angle. Forget complex analysis for a sec. Let's talk semantics. Okay, first big idea. Think of primes not just as numbers but as fundamental building blocks, base objects. Every integer is just a unique mix of these prime bases. Now, order isn't about where they sit on the number line. It's about how they generate and relate to each other. And crucially, we only need finite sets of these primes to build things. No need for an infinite pile up front. This sets the stage for something really neat. Here's the magic trick: mirror completion. Imagine every state has a mirror image d of s equals 1 minus conjugate of s. Think of it like flipping orientation while keeping the phase. If s and its mirror d of s are different, there's still some tension, an unresolved generative relation. But a true zero closure, a perfect cancellation, cannot have this tension. It must be perfectly balanced. Source must equal its own mirror. And mathematically, that means the real part of S sigma has to be exactly 1/2. Boom! The critical line emerges from pure symmetry. Let's quickly map the proof. Start with primes as your basic ingredients. They generate structures with specific orientations sigma and phases t. Completion gives us the mirror d. The key insight: if a system is truly closed, truly a zero, it cannot have an unresolved relationship with its mirror. So the system must identify with its mirror, meaning S equals D. This condition, when you write it out, forces the real part of S to be 1/2. Clean, logical, no numerical heavy lifting needed. So what does this mean? The critical line isn't just a random spot. It's the sweet spot where everything balances out, where a state perfectly mirrors itself. Those zeros? They're not just points where a function hits zero, they're total cancellations, wiping out all non-essential relations. And those infinitely many zeros? They're just different instantiations of the same underlying structure, varying only in phase. It's a beautiful picture of order emerging from fundamental relations. Food for thought, right?